Recording in progress. Hey there, everybody. We're going to record lectures for 3.6. 3.6 is on the chain rule. So chain rule is something we use when we have a composite function, where we have one function inside of another. Like, for example, here I have f of x equals cosine of x to the fourth, where x to the fourth is inside cosine function. So we're going to show how the chain rule gets developed kind of using the limit definition, and then we'll do a better definition or a more useful approach. So we're going to do f prime of a equals the limit. We start off with the blue part. F prime of a equals the limit as x approaches a of cosine of x to the fourth minus cosine a to the fourth, and then we have over x minus a. And then what we're going to do is we're going to multiply by x to the fourth minus a to the fourth over itself. And then we're going to rearrange. We're going to swap denominators. So if we swap the denominators, we have something like this, where the x to the fourth minus a to the fourth is underneath the cosine, and then the x minus a is underneath the x to the fourth minus a to the fourth. Here we're going to split it up, send a limit to each group, like we can do with the limit rules. We do limit on each. And what I did for this side is on the left, I said u equals x to the fourth, and big A equals little a to the fourth, and I did that for the left so that it would look a little different. Something that's helpful here, though. When we do the limit on the right side, you can see the limit as x approaches a of x to the fourth minus a to the fourth over x minus a. That's just f prime of a if we have d dx of x to the fourth. That's the derivative of x to the fourth at a. And the one on the left, if we do this, we have the derivative of cosine of u if u is evaluated at big A, which is little a to the fourth, because that's what we had over here. So the left one becomes negative sine u, and we're going to evaluate that at a to the fourth, which gives us that, negative sine a to the fourth. And this one, we have the derivative of x to the fourth is 4x cubed. We do it at a, we get 4a cubed. So this ended up being, notice that negative sine, if I just replace the a's with x's, then this is the same thing as that. The derivative of f of x is the derivative of the outside function. This is the outside function. Remember, f was, let's write it again here. F of x was cosine of x to the fourth. So this is like the outside function, and this is like the inside. So that we have the derivative of the outside times the derivative of the inside. So this applies when we have composite functions, one function inside of another. This is where we did the f of g of x. And so if we have h of x equals f of g of x, then we do h prime of x equals f prime of g of x, and then times g prime of x. Another way of looking at it is saying y equals f of g of x, and we're gonna let u equal g of x. So we can rewrite this like this, y equals f of u. And then when we want dy dx, or the derivative with respect to x, we first take the derivative with respect to the variable that's present, u, and then we multiply it times the derivative of the variable that's present with respect to the one we want, the du dx. The way I like to think of it is like looking in a box, where, like, when I was young, one of my cousins made my mom a Christmas present. He got her like some nice diamond earrings, really good quality earrings. They were expensive. but he had the little diamond earrings are go in a small box, and he kept putting them in a box and then a little bigger box around it, and he did packaging tape on all of this. And then he had like newspaper in there. So like he ended up with like a microwave sized box on the outside. And I even think it was a microwave box, but there was like 6 boxes inside, and he must have used like 3 rolls of packaging tape or something. But she would have to go in one side to find the next box, go inside to find the next box, go inside to find the next box, keep going in until she found the diamond rings. That's kind of what we do here. If we've got f of g of x, we start this way, we hit the f, and then we keep going inward. We hit the f with the derivative, and then we go inside and do the derivative there. So some steps for doing it, a good approach to doing it. Figure out, well, first off, we've got h of x equals f of g of x. I'll rewrite that right here. So what we want to do is we do want to identify the outer function and the inner function. And then we can find the derivative of the outer function, and we're going to evaluate it at the inner function g of x. And that will give us, like, the derivative of the outer function would be f prime of x. We evaluate or plug in our g of x, and we get f prime of g of x. We also need the g prime of x, so we'll find that, and then we multiply them all together. Okay, and our next video, we'll do some examples.